Hello and welcome class. We are studying chapter number 8 of class 9th NCRT and the name of this chapter is Force and Laws of Motion. And in last class we have completed what is unbalanced force and started a new topic named the first law of motion, and in last class I give you what is the first law of motion. And first law of motion says that if an object is in motion or in rest state, it will continue in its state unless an external force is applied on it. It means that if an object is in the state of motion or is in the state of rest, these objects will stay continuously in their state of motion or in the state of rest unless you have applied an external force to change their state, means to change motion into rest or to apply a force, and you have changed the rest state into a motion state. And this is the first law of motion which explain about the inertia. Inertia is the tendency of a body to stay in their state. Okay, that's why first law of motion is also known as the law of inertia. And in last class I give you one example that if you are sitting in a bus and the bus just started, your body will fall backward. Okay, and if you are standing on a bus and and the driver suddenly hits the brake, your body will uh, uh, fall, okay, backwards. Your body will fall backward. Why this is happening? Okay, when the driver hits the brake, your body will fall forward, and if the driver started, your body will fall backward. Why it is so? We will try to understand. So in cars, they provide self safety belts so that if any person hits a sudden brake, your body does not fall much in forward direction. Okay. We also encounter a situation when we are standing in a bus and the bus begins to move suddenly. You are standing on a bus and the bus begin to move suddenly, your body will fall backwards. Why it is so? It is so because, okay, you bus, surface of the bus. So your feet are in contact with the floor of the bus. Feet are in contact with the floor of the bus. Okay, so if the bus suddenly start moving, your floor which is in contact with the floor will start moving. But your upper part of your body, okay, is in rest position. Okay. Lower part is in motion now and upper part is in rest position. So your feet will go in forward direction and your whole body will fall in backward direction. Clear class? And why it is so? Why your upper part of your body is not changing its state? Because of inertia. Because of inertia. Rest of our body opposes this motion because of inertia. Our feet, okay, are in motion, but our upper part of our body is resisting this motion because of inertia. When a motor car make a sharp turn with a high speed, okay, when a car take a sharp turn with a high speed, we tends to get thrown on to one side. This is also because of the law of inertia. Our body is wants to move in a straight line, but the car has taken a sudden turn. So what happened to our body? Our body will get thrown on the one side of the car. Clear class? When an unbalanced force is applied by the engine to change the direction of the motion of the motor car, we slip to one side of the seat due to inertia of our body. The fact that a body will remain a state at rest unless acted upon an unless unbalanced force can be illustrated through the following activity. Okay, there are some activity. Have you ever played carom board? Then most of the you will easily understand it. Okay, this is the carom board. What one person did? One person stack up all the coins of the carom board, okay, and made and formed a tower. This is your striker. You hit uh, you just hit the striker very fastly so that that striker hits the lower coin. Then what will happen? The lower coin will get out from this stack and all other coin will be in still in the standing position. Why it is so? That when you hit with striker, the when the striker hit the last coin of that, okay, stack, that coin moves away and all other coin are still in their same position. It is because of the inertia. All the coins are in the state of rest. When striker hits the last coin, it come in the state of motion and moves away, but other are still in the rest state, so they will all fall down, fall vertically. Okay. So attempt a sharp horizontal hit at the bottom of the pile using another carom coin or the striker. If you hit it strong enough, the bottom coin will move out quickly. The bottle coin will move out quickly. Once the lower coin is removed, the inertia of other coin make them fall vertically on the table. Because they all are in rest, so inertia will let them fall vertically on the table, but their state is not changed. They are still at rest. Only the last coin where the striker is getting hit will come in motion. Okay. This is the diagram. This is the carom board. You have stacked up some coin. Okay, you hit the striker and the striker hit this end coin. This end coin will come in motion. Okay, it will come in motion, but all the other coin are still in the rest state and they don't want to change its state, so they all will come downward. Okay, there is another example. Okay, take an empty glass. Put a a playing card on the above the empty glass, and on this card put a 5 rupee coin on it above it. Okay. What will happen if you uh, lift if you pull out this card very fast, or okay, or try to flick this card, okay, so that it will move away? What will happen with coin? So you will see that you're going to see that this coin is in rest state, correct? This coin is in rest state. When you will flick the card, okay, with your hands very fastly, this card will come in motion. But this coin is in rest state. So this card, you will easily able to remove this card and the coil, because it is in rest state, so it will fall in the glass. Okay. Because this coin does not want to change its state. If this coin is in rest state, it will remain in rest state. You have applied force on the card, so this card will come in motion state, but the state of this coin will not change. So set a 5 rupee coin on a stiff card covering an empty glass tumbler standing on the table. Okay. Give the card a sharp horizontal flick with a finger. If you do it fast, then this card shoots away. Allow the coin to fall vertically in the glass tumbler due to inertia. Okay. Because this coin was in the state of rest, so the inertia will try to maintain that state of rest even if we have give this card a force. Is it clear, class? So this is the glass. You have placed a coin, a card, and above that card you have placed a coin. You have given a very quick flick with your fingers. So this card will fly off, but the coin is in rest state. So coin will fall in the glass. Another activity: place a water-filled tumbler on a tray. Hold the tray and turn around fast as you can. We observe that the water spills. Why? Okay. Observe the groove is provided in the saucer of placing the teacup. Observe that a groove is provided in a saucer of the placing of a teacup. It prevents the cup from toppling over the case of a sudden jerk. Okay. Place a water filled tumbler on a tray. Okay. Water is completed filled and you have placed it on a tray. Hold the tray and turn around very fast. Okay. Hold the tray and turn around. What will happen? The water will spills. Why? If you turn around, this is because the water is in the state of rest and water does not want the its position to get changed. When you turn around very fastly, you have applied force on the glass. So the glass is in motion, but the water is in rest position. So water will spill from the tumbler. Okay, that's why when with the tea you have provided a saucer so that you cannot spill the tea everywhere. Okay. So, till now, we have studied what is the first law of motion and we have studied about inertia. Now, let's differentiate between inertia and mass. How inertia and mass are related and why they are different with each other. So, all of the examples and activity given so far illustrated that there is a resistance offered by an object to change its state of motion. And that property of object is known as inertia. If any object is in the state of rest, then it tends to remain at the state of rest. And if the object is tend to keep, and if it is moving, then it tends to keep moving. If an object is in the state of rest, it will remain, it will tend to remain in the state of rest. And if it is in the state of motion, that it will tend to keep in motion. And this property is known as inertia. So does all body has same inertia? What is the measure of inertia? We know that it is easier to push an empty box than a box full of books. Okay. In similar, if we kick a football, it flies away. But if we kick a stone of the same size, of equal force, it is hardly moves. There is a ball and there is a stone. The size of stone is same, the applied force is same, okay? But if you kick the ball, the football will flies away. But if you kick the stone, nothing will happen. Both were initially at rest position. You applied the force, okay? Ball changed its state in motion. Stone doesn't change its state. Okay, it was still at the rest position. Why it is so? And there is another factor come here, which is mass. The mass of ball is very low in comparison to mass of stone. If any object has higher mass, then its inertia is also higher. Okay, we have done an experiment of flicking the coin. Let's suppose we first place a 5 rupees coin. If we placed a 1 rupees coin, then what will happen? If we flick the coin, okay, flick the card, the 1 rupee coin will also come in motion very easily. A force that is just enough to cause a small car to pick up a large velocity will produce negligible change in its motion of a train. This is because, in comparison to the cart, the train has much lesser tendency to change its state of motion. Uh, there is a train and there is a cart. If you apply a force on the cart, it will easily change and reaches a high velocity. Okay, and there is a train, okay, in which you will apply force but nothing will happen. It will not change its states easily. So it means that the train has more inertia. And why it is has more inertia? Because it has greater mass. It is more massive. So any object which has higher mass will have large inertia. It means it will change its state less. So it means inertia of an object is measured of its mass. Okay. Higher the mass, more will be inertia. Higher the mass, more will be inertia. Higher the mass, more will be the inertia. And if the inertia is more, then object will tend to resist the change. That's why when we kicked the football, it changes its state very easily and easily come into the motion condition. Changes its state from rest to motion. But when we kicked the stone, okay, it haven't changed its position because the stone is very massive. The mass of stone is very much greater than the football. And if any object will have more mass, its inertia will be larger. And if its inertia is larger, it means it will resist the change very easily. Okay. So, mass, this is the definition of mass. Mass of an object is a measure of its inertia. Okay, mass of an object is a measure of that object's inertia. Okay, if any object has more inertia, it means it has higher mass, and vice versa. Now, let's find out the answer of few questions. Question number one: which of the following has more inertia? A rubber ball and a stone of the same size. There is a stone and there is rubber ball. According to you, which has more inertia? And your answer will be, ma'am, stone has more inertia. Why stone has more inertia? Because it has higher mass. This correct answer is stone. Now, which one has more inertia, a bicycle or a train? And the correct answer is train, because train has higher mass. Which has more inertia, a 5 rupees coin or a 1 rupees coin? And correct answer is 5 rupees coin, because 5 rupees coin is heavier than 1 rupees coin. So the correct answer is stone, train, and 5 rupees coin, because they have more mass, and higher the mass, more will be the inertia. Is it correct, class? Okay. Now let's move on to next question. Next question is, in the following example, try to identify the number of velocity of the ball changes. How many times the velocity of ball changes? Now understand that if velocity is getting changed, it means there is a force involved in it. Okay. So a football player kicks a football. There is a football player kicks the football. So if the football player will kick the football, its velocity will change, and that football is passed to another of his teammate who kicked the football to the goalkeeper. The goalkeeper collected the football. So the goalkeeper has collected the football. It means there the ball has come to a rest position, and that goalkeeper throw that football to his team player, to his own team player. So there are four times where the velocity has changed. One time when the football player kicked the football to his team member. Okay, then that member kicked the football towards the goal, but goalkeeper collected it. So there is a third time velocity change, and then that goalkeeper has thrown that football to another player. So there is fourth time velocity change. Okay. Given below are the number of times the velocity change. First, when first player kicked the ball towards the another player. That was first time. Second time when that second player has kicked the ball towards the goal. Third time when the goalkeeper collected the ball. And fourth time when the goalkeeper kicked the ball toward his own. So the velocity of ball changes four times. Is it clear, class? Explain why some of the leaves may get detached from a tree if we vigorously shake it. If we vigorously shake any tree, okay, why some of the leaves get detached? What is the correct answer of it? And the correct answer is in inertia. There is a tree. Okay. So, so if there are some leaves which are dried, okay, it means they are attached with the branches of tree with very lesser force. And if we try to shake this tree, if we will shake this tree, then what will happen? Initially, this tree is in the state of rest. When we shake the tree, okay, it will come in the state of motion. But leaves will try to resist this change due to inertia. Those leaves are in rest state, but tree is now in motion state. Because of this, uh, a force is generated and the leaves get detached. Okay, class? We know that the leaves are attached to the tree and are in the state of rest initially. But when we shake the tree vigorously, the branches of tree come in the state of motion, but leaves tend to maintain the state of rest. That's why they get detached and fall from the tree. Is it clear, class? Now let's solve next question. Why do you fall in the forward direction when the bus brakes to stop, and fall backward direction when it accelerated from the rest? And the correct answer is you are standing on a bus. Your feet and the surface of the bus are in contact. So if initially bus was at rest and then what happened? It start accelerating. So your legs will also start accelerating, but your upper part of your body is still in the rest. So legs are moving forward, body is in rest, so you will fall backwards. And in another case, where this is the surface of the bus, a person is standing there, okay, okay, and the bus is in motion. Bus is in motion, so you are also in motion. If a sudden brakes are applied, then your legs will stop moving because bus is also stopped. But your upper part of your body is in motion. So you, according to your upper part of your body, you are still going in this direction. That's why your body fall forward. Is it clear, class? Okay. So initially, when the bus is at rest, our body is also following the same state. Your body is also in rest. But all of the sudden, when the bus started, the lower part of our body tends to move with the bus and it will come in motion. But upper part of our body rejected the state of motion and continue to be the state of rest. So our upper part of our body felt suddenly jerk backward, and when a person is standing on in a moving bus and when a sudden brake is applied, the lower part of our body comes to the state of rest, but upper part of our body resists this state of rest. It is continuously in motion, so we tends to fall forward. Okay, and with this question, our first law of motion is completed. Okay, first law of motion or law of inertia is completed here. In next class, we will begin with the second law of motion, where we are going to derive the expression of force and going to learn about a new term named momentum. So today's class is completed. I hope you have learned a lot from it. Now we will meet in next class. Thank you.